Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video.
Now that we've managed to create a number of nighttime light images for different years for both data sets, and we've also created temporal difference images of those data sets for specific locations, we can progress to the next step, and that is to generate a couple of basic statistics and some additional graphs and tables. And that will be the focus for the next one or two tutorials. So we'll continue with our use of the nighttime lights data sets. So remember, we go to our Earth Engine. We use the platform button to get to the code editor. Once we're in the code editor, you're simply within the scripts folder. You just basically scroll down until your saved script. You double click on the script and it will open. As I mentioned in my previous, or can't remember which one, but in one of the previous videos, as a matter of course, I always save it when I open it, and I simply run it as well. And I run it just to make sure there's no errors and so forth and so forth. Because who knows what may have happened. There could have been a problem with the saving or whatever the case may be. So I always run and save it as a matter of a first step. Remember, we've created a number of images, which is the images for different years. 2 years to be specific for each of the data sets. Let's call it the beginning and the end period. And then we've calculated a temporal difference image for each of those data sets to determine locations with recorded increases or decreases or none of the above over that specified periods. We've also played around with the colors, the color schemes and the visualization parameters to give it a bit more visual impact, etc., etc. So what I want to do now is to say, okay, within those temporal difference images, can we generate the statistics in terms of the number of locations that recorded increases or stayed the same or decreases in nightlight intensity, and also the range, what was sort of the lowest or the the highest temporal difference or the lowest temporal difference or whatever the case might be. So I want to create a couple of statistics to augment or to add to the temporal difference images. So I'm going to use the statistic, the histogram function within the Earth Engine. Okay, so there is, okay, before I get to that, remember we've saved, in our last tutorial, we said we're going to save all these images to my Google folder drive or to your Google folder drive, from where we can then export them into let's say QGIS or ArcGIS or whichever GIS program you prefer to work with. So just to confirm, we press the run function button here, and that will give you a window. You just simply continue. Please remember to keep no spaces. There mustn't be any spaces in your names of your images. Just to confirm, remember we said that we're going to save it to my folder. The name of the folder in this case is Velder. So just confirm there is the folder within my Google Drive. If I double click on it, you'll see there is all 6 images loaded in my folder. Just confirm there's 1, 2, 3, 4, 5, 6 images that we've generated, and we have exported them, and all 6 are in my Google Drive folder. Now from here, I simply can just download them to wherever on your hard drive or on your laptop or cloud or wherever. And from there, obviously, you can then just import them into your GIS program, with, as I said, whether it be QGIS or ArcGIS or whatever the case might be. Okay, so but just also on this point, just remember that there is size limitations on these images. So just bear in mind that you can't export, for example, very big or images that covers, let's say, the whole world and things like that. It may be necessary if you, let's say, have a sizable area, that region of interest, it might be necessary for you to download them into smaller pieces and then just add them back into your GIS program to add them and to merge these images again to get to your background. But yeah, so just remember there are size limitations within the Earth Engine. Okay, so then what I want to do is to generate a histogram of my temporal difference images. Now I can also generate histograms, obviously, for my normal images. For, let's say, the 1992 DMSP image, I can generate a histogram. So for all of these images, I can actually generate a histogram. But for the purpose of this tutorial, I'm only going to generate two histograms. One histogram will be for the DMSNP temporal difference image, and the other one will be for, or the second one will be for the VIIRS temporal difference image. Remember, the DMSNP temporal difference is the difference in night light intensity per location or from a region of interest from 1992 to 2013. And my VIIRS temporal difference image is the temporal difference from 2013 to 2023. So the code is fairly straightforward. You use the export to drive um, uh, 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 instruction, and which image we're looking at. Sorry, histogram. We're using the ui.chart.image.histogram instruction. Remember, there's my name, the variable that I'm creating, and again, that's up to you. It's up to your discretion. In my case, I'm calling it histogram DMSP. So that it's set, it's totally up to you. And I'm using this instruction, which is the histogram instruction, which image that I want to create a histogram with. I want to create an histogram by subtract DMSNP, which is this particular one. Subtract DMSP. If I want to see the formula, it is 2013 minus 1992. So that's the image that I want to create a histogram. My region of interest is the one. The scale is just the size of it. And then here, min bucket width is just the size of your bins, meaning the difference between in the range, so to speak. So we're going to play around with this. And then I have the code print. And then what am I printing? And print just basically mean is display that histogram in the console function. And this is the histogram. I've already run the code. Obviously, you're going to run it. Okay, so, and I just copy and paste that code, and I just change the histogram parameters or the variable from the DMSNP to the VIIRS. But the codes are exactly the same. So, and remember to print, to include the print function, because that basically instructs the editor to display it. So let me just run it again, just for completeness sake. You'll see, obviously, every time you run the code, it will ask for you to export those images. So you can just ignore it because we've already done it. And then, as I said, let's make it bigger. Let's run it again. The size of this window will determine the size of the histogram. So if I make that window bigger, the histogram will be bigger as indicated. So there is my histogram of the DMSNP. And there's my histogram of the VIIRS, of the VIIRS temporal difference images. And you can see the bin is 5 numbers, or 5 intervals of 5 values, from -15 to -10. So we can assume that there was a region that recorded a decrease in -15, and we can assume there was a region that increased +50. Well, that seems to be the maximum range, but we don't know for certain. And this is the VIIRS. You can see the VIIRS, the range is much higher than in the DMSP. Now, you can see there the count. There's 892,697 regions that recorded a change of 0. And there is roughly, let's go there, 12,000 that recorded the change of 5, plus minus. So almost a million. And around +5, and here is also plus minus a million, it's around 0. In this case, there is some that recorded a negative, it's about 13,000, etc. But you can see it's very difficult to interpret the tables, the histograms in this window. So there's a little function there, which basically means you can expand this and you can download the histogram. So let's click on that button there. Remember that little button, it says expanding. So we click on that and a new window will open, and it now much more clearer. You can see there is there was 12,000 that recorded an increase of up to 5. There was about 4,000 that recorded the increase up to 10. There were some that it's difficult to say, and there's some that doesn't. Yeah, there's some. Let's go there. Somewhere. It's so difficult. You have to place it perfect. Okay, so there was about 2,880 that recorded a decrease in nightlight intensity. So it seems like um, the biggest decrease was -5, and the biggest increase seems to be some there of 25. But 90% of the variables recorded the increase of between 0 and 5 in their nightlight intensity from 1992 till 2013. Now, we can what is nice about this, we can actually download this whole histogram as a CSV file. So let's quickly just do that. I'm just going to download it to my desktop for simplicity, and I'm going to open it. Now that it's downloaded, I'm going to open it. I'm just waiting for the CSV file to open. There it is. Now it's in CSV file context, so I'm going to go to my data, and I'm going to go text to columns. I'm going to use delaminated, and is it comma, and then choose where I'm going to locate the amended data set, and I press finish. Let's center that one there. Let's left align it there, and there you can see. So there's actually 36 locations that recorded a decrease of -15 in their nightlight of intensity. There's 300. Let's make it a bit bigger. Let's make it a bit bigger. Let's hide this now. We don't need that specific one. Yeah. So there's 36 locations that recorded a decrease of -15 in the nightlight intensity over that period. There's 342 that decreased -10, and so forth. The vast majority, as I said, of locations recorded no change, simply because there most probably wasn't any nightlight available. Could be farmland, dams, forest areas, mountains, whatever the case might be. 12,005, and there's, interestingly enough, 45 locations that recorded a nightlight intensity of 50 or more. So there's a nice histogram of the areas, which gives you additional information of the temporal difference. So yeah, or you can download it as a CSV, or you can download it as a picture. That is totally up to your discretion. So if I close this, I can do exactly the same for the histogram of the VIIRS temporal difference image, and I can download it there. And I'm saving it as well. And let's do that quickly. See what's happening there. Let's open that chart. As I said, it will be in CSV format. So I'm just going to use my Excel text to column function. And I know it's a column and a function to basically just convert it from a CSV into an Excel. I press finish. Let's make it a bit prettier. The bands, the bins, I'm going to left cent values, I'm going to center. I'm going to hide this. And I'm going to make it bigger. Okay, and here you can actually see that there was one location that recorded a decrease of 95. That's very big, so yeah, I know this might be an anomaly. There's 6 that it recorded decreases of minus 80, 4, etc. The vast majority is again under the 0, but you can see compared to the DMSNP, where the vast majority, or not the vast majority, but from the locations that recorded changes, the majority of them were recorded increases in the night light intensity and not decreases, and exactly the opposite with the VIIRS. The majority of the locations that recorded changes recorded decreases compared to increases. So just a different way of presenting the data as well. And let's close that. Yeah, so I've created now 2 histograms for each of the temporal difference images. And okay, let me quickly just change if you the size of the bins. If I make that 10, just to have a look, remember it's 555. If I press run now, it should come up as the bin sizes will now be at 10. And again, you can export them into CSV and then convert it into Excel for further work with. You can see the bins are now 10. But in this case, you lose, because the values are so marginal, it doesn't make sense to use bins of 10s. I think bins of 5 or even bins of 2 should be, I think, much more efficient, because you won't lose the detail, the marginal detail, as if you go with a, let's say, bin size of 10. Now you can see that the sizes are now basically, it's just displayed as 4 because just the window is so small. If you open it up, you can actually see the bins are now in 2s. So that gives you an idea, or gives you the code of creating histograms in the Earth Engine itself. And then from the histograms, you can export it into Excel. And so now you will have the images that you can work with in your preferred GIS system, and you have some data that you can use in Excel to augment whatever you want to do with those data that preferably you can't do in the Earth Engine. But importantly, the Earth Engine gives you access to the source image, and it gives you access to the source data from where you can do whatever you want to do in other programs specifically designed for those specific tasks. So that is it for this particular tutorial. I hope and I trust you enjoyed it, and stay tuned. The next one will be located, or will arrive very, very soon. And thanks for joining me on this journey of remote sensing. We're exploring uncharted territory together.